Okay, so if you've been given a problem where you need to find an equation and you've been given one focus and one vertex, and you're also told that the ellipse is centered at the origin, well, I guess even if you have a problem with an ellipse to begin with, the first thing you'll need to know is the standard form of an ellipse, or basically what it looks like once it's written out as an equation. So that's it right there. X squared over a squared plus y squared over b squared. Now, depending on where the major axis is, the a squared could be under the x or it could be under the y. And I'll show you what's going on in this one later on. Second, what you'll need to know is that if you've already been given one of the focus or one of the foci and one of the vertices already, so you have right there 0, 5 and 0, 6, knowing that your other vertice your other vertex or your other focus is just going to be the same number with a negative in front or a negative added to it. So in this case right here we have 0, 5 and 0, 6. That'd be like writing 0, 5, or excuse me, 0, 6 and 0, 5 in front of this right here, replacing your A with 6 and C with 5. And to summarize briefly what I just said right there, if your origin is at 0, 0, once you are given one vertex or one focus, you can find the other simply by adding that negative onto in front of it. So, whoopsie daisies, that wasn't supposed to happen. A little too much information all at once. So if your a squared is just taking your a and squaring it, you'll be left with 36. And if your focus value, which was 5, is squared, making c squared, that'll be 25. Now what you can do, because we need to find out what the b value is in order to get back to that original equation right here, or to put something into this form, what you'll need to first do is find your b squared value. You can use the fact that c squared is equal to a squared plus b squared, or by manipulating the equation, find out that b squared is equal to a squared minus, there we go, I think you can see that now, c squared. So essentially, b squared is equal to a squared minus c squared, and you're left with 11 after you do that. So given from the last page that your a squared value was 36, your b squared value was 11, and that your c squared value is 25, a and c right here are going to be positive 6 and positive, or excuse me, positive and negative 6 and positive and negative 5 respectively, and they are on the y-axis, and that was given from the original start of the problem where it stated that they were at these points right here. So, coming back to that, because these are in the position of the y's, and you have a negative y right there and a positive y right there, your major axis is going to be on the y-axis. So, going back to what I said at the start of the or towards the start of the video, where your a and b would be over or underneath actually x and y, depending on. You know what? Let me just try and restate that again and make it a little bit simpler. Your a squared value is going to be where you pull your vertices from. So right here, for example, a and 6. So if you were to write that out, you would get these values right here. So this would be like writing 0, negative a, and 0, positive a. In this case, your major axis is on the y-axis. So you write your a squared value under y, and your b squared is going to go under x. So after you've done that, this is what your equation will look like. X squared over 11 plus y squared over 36 is equal to 1 is the equation you were looking for if you were given this problem.